So students, welcome back to this channel where I try to make math a bit more fun. And today we are once again going to get into idea series, inverse trigonometric function series, and I think this is going to be the last video of the series. I don't know what is the number of videos this is. Anyway, today we are going to be focusing on practicing a few important questions. So let's get right into it. Hmm. Let's see what we can do. Let's once again begin with an easy one. This asks us to evaluate this expression tan inverse of 1 plus cos inverse of minus half plus sine inverse of minus half. Now you can definitely change this expressions into all sines or all cos or all tans. That would work too, but that is gonna consume a lot of your time. So what I would recommend doing is, you can see that uh, the values we have been given inside of this tan and cos and sine functions and inverse versions of this are actually very easy to remember. I would recommend memorizing a few trigonometric values because I mean at the end of the day, trigonometry is like hugely dependent on that. There are some trigonometric values which we have to remember. Like we have to remember that sine 30 degrees is half. So Uh, I mean, there is no way around it. We will have to memorize that, right? We can definitely draw a right angle triangle and let one of its angles be 30 degrees, and then we can definitely find what would be the sine of that angle. But that is going to consume a lot of time. So definitely a few values should be memorized, and that's what I'm doing here. First of all, tan pi over 4, that is 45 degrees. I would expect everyone to memorize this. Already, I mean, we've been probably taught about this since I think 10th standard it was, and by 5 or 4, or then 45 degrees is 1, so that means tan inverse of 1 is pi over 4. Cos 2 pi over 3 is minus half. 2 pi over 3 radians is the same as 120 degrees. So that means cos inverse of minus half is going to be the same as 2 pi over 3. And we can rewrite this plus sine inverse of minus half as minus of sine inverse of half. We know that, as far as I remember, I have talked why this happens in one of the previous videos in this series. I mean, I think that has been done. If it has not done, let me know in the comment section. I'll need to make another video on this, like sine inverse of minus x is the same as minus of sine inverse of x, and cos inverse of minus x is the same as just cos inverse of x. I think I've talked about this already, but once again, if I have not, then let me know about that in the comment section. I will definitely make videos on them. Now, sine pi over 6 radians, that is 30 degrees, is half. That means sine inverse of half is pi over 6 radians or 30 degrees. Now, applying these values here, plugging in these values, tan pi over 4 is, sorry, tan inverse of half is pi over 4, cos inverse of half is 2 pi over 3, and minus sine inverse of half, that is pi over 6. Now you can definitely easily calculate what would this value be. The LCM is going to be 12, and the numerator would have 3 pi plus 8 pi minus 2 pi, that would be 9 pi plus 12. This is the same as 3 times pi over 4 radians, or 135 degrees. Okay, this was the first problem of this video. Let's see how many difficult questions we find. These ones are pretty easy. I think we should be able to get this one easily. Yeah, let's then try this one. This one actually. Hmm. Let's say. Actually, wait a second. No. Let's try to evaluate something like sine inverse of, let's say, a plus 2 times tan inverse of b. See, like, these are the probably hardest level questions we will find in this chapter. This is why this chapter is, I think, one of the easiest in the entire 12th standard. So, this will be the same as sine inverse of a plus, we know the formula of 2 times tan inverse of b. We have already talked about this in one of the previous videos. This is tan inverse of 2b over 1 minus b square. Now, I have two choices. Either I can change both of the expressions, like both of the parts of the expressions into either tan or basically what I can do is I can change either this as tan of something, tan inverse of something, or I can change this one into sine inverse of something. Let me actually the tan one. Let's change this one into tan one. So this is the same as, again I have already taught about all of this in the previous videos. This will be the same as a over root over 1 minus a square. Let's see what you have here is tan inverse of 2b over 1 minus b square. So this would be the same as tan inverse of a over 1 minus a square plus 2b over 1 minus b square uh, over 1 minus a times a, this term is a times 1 minus a square times 2b times 1 sorry 2b times 2b over 1 minus b square. Okay, these are probably the hardest ones you will get in this chapter. Let's see if I can find a bit more difficult ones. These are all pretty easy ones. Let me try something like let's try something like let's say tan inverse of 2 times tan inverse of x is the same as sin inverse of k. We're asked to uh, if find the value of k. So I can rewrite this 2 times tan inverse of x as sin inverse of I have already talked about this in the previous videos. Sin inverse of 2x plus 1 over x 1 plus x square 2n over 1 plus x square and the right side would remain the same, and now we can easily say that k equals 2x over 1 plus x square. These are the hardest level questions you will get. I'll try to find a bit more harder questions in the next video. I told you that this is gonna be the last video, but I think I should try to find a few more difficult, comparatively difficult numericals. I know that I probably won't be able to find that many difficult numericals because this chapter is only just at the seat already. But I'll try to. But I'll still try. Oh, okay. Anyway, I think this is where I'd like to wrap this video up. Even though this video is very short, that is because I am just not being able to find, worth noting numerical problems. Let's see what can I do in the next video. And if you guys think that you have any doubts regarding anything I've taught in this video, as always, you can tell me about that in the comment section, and I will try to resolve your doubts. Until then, goodbye and keep learning.